PVectors are great by themselves. They can really make your code look cleaner. Where they get really exciting though is when we make an array out of them. Let's see how to do that. To create an array of PVectors, we just do the normal thing. We declare a PVector, followed by an open and closed square bracket, a space, and the name of the variable. Here I'm going to call it plist. So this is the syntax for declaring the array. Let's go ahead and flesh it out. So here's my first line. When processing sees this, it says, aha, I'm going to create a thing that ultimately will be able to hold a whole bunch of PVectors. So I'll make that box. But there's nothing inside it yet. Just like any array, it's a potential waiting to happen. Now I'll fill it in with real PVectors. I'll say that plist is made up out of, let's say, 10 actual PVectors. So that's what this syntax does. Just like any other array, I say new PVector with square brackets, and that tells it make 10 of these. So okay, off it goes, and it will make 10 little placeholders inside of this list. Here I'm showing just the first few, so I can make them nice and big, but the list continues off screen to the right. But again, these placeholders don't have PVectors inside them yet. They are boxes that are ready to hold a PVector. So let's go ahead and fill them in. I'll write a little loop that runs a variable I from 0 to the length of the list. Of course, I know that's 10. By writing it this way, if I later decide I want a length other than 10, say 5 or 20, I only have to change that in one place where the array is created. If I put the number 10 directly into the loop, I'd have to remember to change that as well every time I change the length of the array. If I change it in just one place but not the other, my program can start to go haywire or even crash. To prevent that, the number 10 appears in just one place, and everything else that needs the length of the array refers to plist.length. For every value of I, I'm going to create a new PVector and stick it into plist sub I. And I do that by writing exactly that. I say plist sub I equals new PVector. And I'll give it the starting values 0, 0, because I have to give it something, so 0, 0 is a nice thing to give it. So let's think about this loop. The first time through, I is 0. So I'm saying plist sub 0 is a new PVector whose initial values are 0, 0. So looking up at the picture, we say, okay, the first thing we do is we create a new PVector. Of course, that has two values, x and y, and we set them both to 0. The name of this PVector is plist sub 0. It's the first element of the array. And that element happens to be a PVector that holds an x and a y. Now returning to the code, we're done with the loop. We go back up to the top of the loop. Now I has the value 1. And now we say plist sub 1 is a new PVector. Going back to the picture, okay, we create a new PVector, we stick it in that element of the array. It has a built-in x and y, we set them both to 0, and now that thing is plist sub 1. Well, around the loop we go, we make the next PVector, and now that's plist sub 2, and so on. We just keep going through the loop, making new PVectors until the whole array is filled up with actual PVectors. Now that we've done this, how do we talk to the individual elements? Well, notice that the first element is plist sub 0, and that has an x and a y inside of it. So the x value is nothing more than plist sub 0 dot x, and we can read from that or assign to it. The y value is nothing more than plist sub 0 dot y. How about the next element? That's element 1 of the array. So that's plist sub 1. It holds an x and a y as well. So we have plist sub 1 dot x and y. The next element, it's the same thing. That's plist sub 2. So the x element is plist sub 2 dot x, and there's also plist sub 2 dot y, and so on for all of the elements in the list. Of course, we could do this with two arrays, an x array and a y array. The PVector just lets us bundle things together, and that often gives us cleaner, shorter code that's also easier to debug. Let's look at a couple of examples of using arrays of PVectors. Here's a little program that uses 3 arrays of PVectors, one for each of these 3, well, sort of waves. Each one of these waves is nothing more than an array of PVectors, an x and a y. I draw the wave by drawing a Catmull-Rom curve through all the points of the wave. Then I just randomly jiggle the points around. So they don't really behave like waves, they behave like curves that are moving around randomly, but they have a kind of a nice effect. Here I'm using lots more waves, and you get a kind of a nice 3D kind of a feeling from this. Again, there's nothing more here than a bunch of arrays of p-vectors whose points are moving randomly on each frame. Just for fun, let's take away the lines. Well, it's pretty much the same thing, but it has kind of a nice murky feeling to it. This was a very easy program to write. I'm sure that you can imagine all kinds of creative variations that use this simple program as a springboard to much more exciting and personal programs. In part 2, we'll look at the code for this little program, and we'll see how to actually create and use arrays of p-vectors.